Hello and welcome to Collab. This is our UTME prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are going to look at the UTME or JAMB questions for physics for the year 2018. This is the second part, the concluding part of the recording. We are going to look at the next 20 questions. Before we continue, don't forget to subscribe to our YouTube channel, like and share our content, and also leave a comment in the comment section below. You can also check out our website at collab.com to practice UTME exam and modular quizzes for free. Okay, the first question here on Soundwave. The pitch of an acoustic device can be increased by. So pitch is affected by frequency. Okay, so the pitch can be increased by increasing the frequency. Now there are certain attributes of sound like pitch, quality and loudness, and there are factors that determine this. Okay, pitch, for example, is determined or is affected by frequency. Quality, the quality of sound is affected by the overtones, is determined by the overtones, while the loudness is determined by the amplitude. So a simple way to remember this is to use this mnemonic here. Okay, Professor Collar is a Lagosian. So professor, here you have the P and F, meaning pitch is affected by frequency. Then in the collar is spelled Q-O-L-A. So you have Q and L there. So meaning I'm a Q and O. Okay, so meaning the quality is affected by what? The overtones. Then you have Lagosian, L-A. So meaning L for loudness, affected by A, amplitude. Next, on nuclear physics, one of the features of the fission process is that it leads to a chain reaction, that is continuing reaction, where the daughter elements that are produced from one reaction are going to go on to break down again and produce new ones. Next, on expansivity. The linear expansivity of brass is 2 times 10 raised to the power minus 5 per Celsius. If the volume of a piece of brass is 15.00 centimeter cube at 0 degrees Celsius, what is the volume at 100 degrees Celsius? Alright, so we are given the volume, the linear expansivity, okay, as 2 times 10 raised to the power minus 5, and we are given the initial volume, okay, the volume that is at this temperature, which is the original temperature here. At this temperature, the volume was 15 centimeter cube. Okay, so let's say that is V naught. Now the question is, what is the volume at 100 degrees Celsius? Let's just say that is V2. Let's just denote that as V2. Now what we are going to look at is what is the change in the temperature, okay, of that brass. The change in temperature here is this new temperature, that's 100 degrees Celsius, minus the old one, which is 0 degree Celsius. So the change in temperature here is 100. Now the formula is volume expansivity is equal to change in volume over the original volume times the change in temperature. Okay, that is the formula. However, we've not been given volume expansivity, so what do? Okay, we can get it from this linear expansivity here. The volume expansivity is going to be equal to 3 times the linear expansivity. So we're going to have 3 times whatever we've been given at the linear expansivity, and here that is 2 times 10 raised to the power minus 5. So 3 times 2 times 10 raised to the power minus 5. You can just multiply this 2 here, 3 times 2, and that is 6. So times 10 raised to the power minus 5. So this is what we'll be using for our volume expansivity. So when we bring this down into this formula here, we now have 6 times 10 raised to the power minus 5 is equal to the change in the volume over 15 times 10 times 90. Now the question is to find the new volume, okay, at this. But what we want to do here first is to calculate the change in the volume. Why? Because if the original volume is 15, and I know that the change in volume is 1, okay, if the original volume is 15 and I know that the change in volume is 1, that means that the new volume now is going to be what? I'll just add the change in volume to the old volume. Okay, that's just 15 plus 1, and that will be 16. Okay, so what I need to do here first is calculate the change in volume. So continuing from here, we can cross multiply these values that I have here. Just leave this as it is and cross multiply this. So I'm going to have 6 times 10 raised to the power minus 5 times 15 times 19. Okay, now by the time you multiply everything here, okay, how do you multiply this? Just write this as 6, okay, times 15, 6 times 15 times 90 times, now this 10 raised to power minus 5, we are going to write it as 1 over 10 raised to power 5. Okay, 1 over 10 raised to power 5, and 10 raised to power 5 is 1 0 0 0 0 0, that is with 5 zeros, since this 10 raised to power 5. So what does that mean? That after you have multiplied all of this thing here, okay, after you multiply all of this in here and multiply this by this one here, we will then divide it by 100,000, by this 100,000. Okay, and doing that will then give us what we have here. This is 0.09. So this is the change in the volume. Okay, now the original volume is this, Abby. The volume now changed by is 0.09. You can see this is positive, it's not minus. That means that there's an increase in the volume, that the increase in the volume is now 0.9. That means that the new volume is now going to be what? The old volume, or the original volume, plus this increase here, which is 0.09. So this becomes 15.09 centimeter cube. Okay, so this question is repeated. Okay, and commonly you get questions on linear expansivity like this, questions on volume expansivity, where they'll give you linear expansivity and all of that. So I advise that you would like. Next, on laws of motion, a lead bullet of mass 0.05 kilogram is fired with a velocity of 200 meter per second into a lead block of mass 0.95 kilogram. Given that the lead block can move freely, the final kinetic energy after impact is. Okay, so basically the total momentum before collision, that is before the collision between that bullet and that block into which it was fired, is going to be equal to the total momentum after collision. Okay, momentum before collision will be total momentum before collision will be equal to total momentum after collision. Now the formula for momentum is that momentum, represented by this symbol here, is equal to the mass of the body times the velocity of the body. Okay, now we are going to have two momentum here: initial momenta, okay, before collision, and then you have momentum after collision. Now, so on this side you are going to have the total momentum before collision. Now what do you have here? What you have here is, this is the momentum of the bullet, okay, before collision. This is the momentum of the block before collision. Okay, why what you have here is the momenta after collision. Now just like you have m1 u1, this is supposed to be m1 v1 m2 v2, but the reason why we are not using v1 and v2 is because after this bullet was fired into that block, the bullet, we are assuming here that it penetrated the block, and then it moved together with the block. So that means that they are going to have a common velocity. So instead of saying v1 v2, we just say let it be v, that is m1 v. Okay, on this side we are supposed to have m1 v plus m2 v. Okay, plus m2 v. Now since v is common to these two, we can just put this m1 and m2 in the bracket, that is m1 plus m2, okay, plus m2, close the bracket, then I'm going to have v here, the velocity here. So this is that's why I have this. Then we want to make v the subject here, since we are looking at for the velocity. Okay, we want to look for the velocity, so we divide both sides. Okay, we divide both sides by this m1 plus m2. Now in our substitution here, remember this is m1 u1, that is mass of the bullet, the initial mass of the bullet, times the velocity of the bullet, initial velocity of the bullet. So the mass and initial velocity. For the lead block, we have the mass of the block, okay, times the initial velocity. Because this block was originally at rest, meaning it was just standing there, it was not moving, okay, so its initial velocity is 0. That's why you have this is 0 here. Then divided by this is 0.05 mass of the bullet plus the mass of the lead block is 0.95. Remember that this is going to give you 1, and 0.05 times this times 1, that will give you 10. So you have 10 plus 0 over 1, that will give us 10 meter per second. So that is the velocity with which the two bodies move. So the question is how to calculate the final kinetic energy after impact. Okay, so now normally the formula for kinetic energy is Ke, okay, is equal to half mv squared. Okay, half mv squared. But here instead of using m, we are now using m1 plus m2. Why? Because there are two bodies that are moving together now. The lead block, the bullet, okay, the bullet and the lead block. So after impact, this bullet penetrated this lead block and then they move together. So you have two bodies moving together. So you know this will not just be the mass of one thing. It's going to be the sum of the mass of both the bullet and the lead block. Okay, so you are going to be having that mass of the bullet 0.05 plus mass of the lead block 0.95. Then multiply this by the velocity which we've calculated here as 10 raised to power 2. So that's 100. Remember, this plus this will give you 1. So you have 1 over 2 times 1 times 100. Okay, 1 over 2 multiplied by 1 multiplied by 100. And when you multiply this, you see you have here 1 times 1 times 100, that is 100. Okay, divided by these two here. 100 divided by 2 is 50 joules. Next, on AC theory, in a series RLC circuit at resonance, the voltages across the resistor and inductor are 20 volts and 40 volts. What is the voltage across the capacitor? Alright, so in a mixed circuit, an RLC series circuit, okay, at resonance, the resistance R is going to be equal to the impedance Z. Okay, the resistance R will be equal to the impedance Z. The current I passing through that circuit is going to be maximum, and the capacitive reactance will be equal to the inductive reactance. Okay, now if the capacitive reactance is equal to the inductive reactance, that means that the voltage across the capacitor must be equal to the voltage across the the inductor. And here they said the voltage across the resistor and the inductor are 20 volts and 40 volts. That is, the voltage across the inductor is 40 volts. So that must be the same voltage across, the capacitor as well. Okay, so we have 40 volts. It is only by that way that your impedance will be equal to resistance. You can try substituting here. Okay, you can try substituting here for voltage across the resistor as that 20 that have been given, and then you realize that unless this, like this is 40 and this is 40, so that these two can remove, like 40 minus 40 to get is 0. Unless you have that, then this would not be equal to this. Okay, that is what we are saying here would not be correct, that resistance R will be equal to impedance. That would not be correct unless we have this, both of them to be of equal. Next, on nuclear physics, if the fraction of the atoms of radioactive material left after 120 years is 1 over 64, what is the half-life of the material? Okay, so after n times of decay, let's start with what we call half-life to begin with. So half-life is a time that it will take for a material to decay to half of the original mass. Okay, the time that it will take for a material to decay to half of its original mass. Let's say, for example, a substance is originally 100 kilogram. Okay, then it decays to 50 kilogram in, let's say, 24 hours. So that 24 hours there is the time that it took for that substance to decay to half of its original mass. That is, for half of it to decay away. Okay, so that 24 hours is going to be the half-life. Alright, so that's it. Now, after n times of decay, the fraction of the original substance that will remain is going to be 1 over 2 raised to power n. Okay, 1 over 2 raised to power n. Now, if 1 over 64 is the remaining fraction, that means that we just say 1 over 2 raised to power n is equal to 1 over 64. Okay, and this will be 1 over 2 raised to power n equals 1 over 64 is 2 raised to power 6, meaning 2 times 2 times 2 times 2 times 2 times 2. 2 multiplied by itself 6 times. Okay, now if you compare both sides, so you have 1 2 raised to power n 2 raised to power 6. You can easily say that our n is equal to 6. Okay, meaning that this substance has decayed 6 times. It has decayed 6 times. Now if the time, okay, that it now took for it to decay 6 times is 120 years, that means that each of the time each of the time will be what? That 120 divided by 6, 20 years. That will be the time for each of those decay. Okay, the time for each of the decay is going to be 20 years. If it took this if it took this substance a whole 120 years to decay, and it has decayed 6 times, that means that each of those decay occurred in 20 years. That's 120 divided by 6. Next on Soundwave, so we have a diagram here. In the diagram above, which of the simple pendula will resonate when P when set into oscillation? So in a setup like this, okay, in a setup like this, those that are of equal length or about the same length are going to resonate together. And in this diagram, that is T. Okay, the pendulum T is of about the same, not exactly the same, but about the same length as P. So it would resonate when P is set into oscillation. Next on it, the time rate of loss of heat by a body is proportional to the difference in the temperature between that body and its environment. Okay, the time rate at which the body is going to lose heat, or at which the body will cool, is going to be proportional to the difference in temperature between the body and its environment. The greater the difference in temperature, the faster the rate of loss of heat, or the faster the rate at which that substance will cool. We have a website at Collab.com where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at Collab.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. Next on current electricity, a positively charged rod X is brought near an uncharged metal sphere Y and is then touched by a finger with X still in place. When the finger is removed, the result is that Y will acquire negative charge, okay, by induction. So it will have a negative charge and a negative potential. Next on electricity, electrical appliances in homes are normally arted so that it is to prevent shock. Okay, arting electrical devices helps to prevent electric shock or damage of the device during in the advent of thunder or lightning. Next on matter, the process whereby a liquid turns spontaneously into vapor is called, so the phase change from liquid to gas, okay, is evaporation. That is evaporation. Next on introductory electronics, so we've given some diagrams here. Which of the following diagrams correctly or represents correctly an NPN transistor? That is a diagram C here. So you can see it is similar to what we have here for an NPN transistor. Okay, for an NPN transistor, you can see the direction of flow. It is to the emitter. Okay, from the collector to the emitter, just like you have it here. This is the base, this is the collector, this is the emitter, and the direction of flow is to the emitter. Okay, so that is what we have in an NPN transistor. Next on matter, the differences observed in solids, liquids and gases may be accounted for by, okay, so this has something to do with the distribution of particles. Okay, the way the particles have been distributed, the way they have been spaced, okay, or the way they have been packed. This is what is responsible for the physical differences that you have between solid and liquid. Okay, like solids having a definite shape and a definite volume and all of that. So it is as a result of the spacing between these particles and the intermolecular forces that you have between their molecules. Next on optics, Convex mirrors are used as driving mirrors because images formed are. So the convex or diverging mirror, they are used as driving mirrors because the images that they form are erect. Okay, they are erect, they are virtual, all right, and they are diminished. They are diminished. Now the fact that they are diminished allows it allows the mirror to cover a wide range of view, meaning that you can see a whole lot of thing. Okay, it covers a whole lot of thing in that mirror. So this is why they are commonly used as, as driving mirrors and not convex mirrors, because convex mirrors are diverging mirror. Okay, so they will tend to magnify things and give you like a false impression of, let's say, the distance of the object. The convex mirror does that too. Okay, however, one advantage that it has above the concave mirror is that it gives you a wide range of view. Okay, it gives you a wide range of view. You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2, or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, it could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at collab.com, or you could also check it out in the video description below. Next, on Soundwave, musical instruments playing the same notes can be distinguished from one another owing to the differences in pitch. Okay, so note is a function of frequency, and the frequency determines the pitch of the sound. So the difference in the pitch can be used to distinguish the musical instruments even if they are used to play the same note. Okay, so the pitch of those instruments can be used as a criteria, okay, to differentiate between the musical instruments. Next, on magnets, in the diagram above, if the south poles of two magnets stroke a steel bar as shown here, the polarities at T and V will respectively be. So the south pole, okay, will generate opposite pole at the ends here. So that means that at this end you are going to have, say this is south, at this end you are going to be having north. Okay, so you are going to have north on the opposite sides here. Next, on electricity, in ohms, electrical appliances and lamps are connected in parallel because parallel connection uses lesser voltage. Okay, it uses lesser voltage. It also prevents short circuit and breakage. Next, on motion, an object moves in a circular path of radius 0.5 meter with a speed of 1 meter per second. What is its angular velocity? The angular velocity, omega, is equal to the speed of that body, okay, divided by the radius of the circle in which it is moving. So the velocity here we've been given here as, or the speed, as 1 meter per second. So we divide that by the radius of the circle in which the body is moving, which is 0.5. So you have 1 divided by 0.5, and that will give us 2 radians per second, 2 watts per second. Next, on machine, what effort will a machine of efficiency 90% apply to lift a load of 180 Newton if its effort arm is twice as long as its load arm? Okay, so the formula for efficiency of a machine is equal to mechanical advantage over velocity ratio times 100%. Okay, now before we go into this, okay, the question is, you have to find the effort, right? We have to find the effort. What effort? That is the question. It is the effort that we have to find. Mechanical advantage is equal to load over effort. So this is the formula that we are supposed to use directly to find our effort. However, we can see that in the question, the only thing we have here is load. Okay, load 180 Newton. We don't have the mechanical advantage. Hence the need for us to first use this formula here, this formula for efficiency equal to mechanical advantage over velocity ratio times 100%. We need to use this formula first to calculate our mechanical advantage before we then come back to this. Okay, now they gave us the efficiency from the question as 90%. That is a machine of efficiency 90%. We have that. The velocity ratio is 2. How do we know that is 2? Now the formula for velocity ratio is the distance moved by effort over the distance moved by load. The distance moved by effort over the distance moved by load. Now if the effort arm is twice as long as the load arm, that means that the distance that will be covered over the effort arm will be 2 times the distance that will be covered over the load arm. That means that, let's say the length of the load arm is 5, okay, 5 centimeter for example. That means that the effort arm is going to be what? It will be 10 centimeter. And when you take 10 divided by 5, you are going to get what? You are going to get 2. If this one is 20, that means that the effort arm, the length is going to be what? 40. So anyways, you're always going to get what? This 2 here. Okay, you're always going to get this 2. So our velocity ratio here is 2. Now if you substitute that in this formula here, efficiency is 90, that's 90%, equals mechanical advantage over velocity ratio, which is 2 times 100. Okay, so what we have here is this. I would love to write this out so you can see very well. So we have efficiency, okay, is equal to mechanical advantage, the mechanical advantage over 2, multiplied by 100, multiplied by 100%. Alright, so here 2 here 1 and 2 here is 50. This will be 50. And remember that our mechanical efficiency here, they gave us as what? As 90. It is 90. So we have 90 on this side equal to MA times 50, that's 50 MA. To get divided by MA, we then divide both sides by what? By 90. So when you divide both sides by 90, we are going to have what? MA to be equal to 90 divided by 50. So the mechanical advantage is equal to 1.8. Okay, 1.8. So we can now go back to using this formula that we have here. The mechanical advantage is equal to load over effort. Okay, M is equal to load over the effort, and our M here is what? 1.8 equal to the load, which is 180 over effort. When you cross multiply this here, you are going to have effort times our mechanical advantage, which is 1.8. So you have 1.8 E to be equal to 180. Then divide both sides by 1.8. I have E to be equal to 180 divided by 1.8, and E is equal to 100 Newton. So the effort applied here is 100 Newton. Alright, the last recording for this, the last question for this, we have to calculate the effective capacitance of this circuit here. Now if we look at this circuit here, we have mixed connection here. Mixed connection in that some of these devices are connected in parallel and some of them are in series. Now these 3 here, they are connected in parallel. Okay, these 3 capacitors, they are connected in parallel. Now what we need to do here is this: we want to find the effective capacitance of what we have here. Okay, so we are going to first look for what is the effective capacitance of these 3 that are in parallel. Whatever we now get for the effective capacitance is now going to be in series with these other ones here. Okay, let's say we calculated this, we calculated this and we got, say, 1 for example. That 1 microfarad is now going to be in series with these 2. Okay, so let's go on to calculate this. Now remember that when you have capacitors in parallel, how do you find the effective capacitance? You just add up those capacitors, the capacitances rather. You add up the capacitances. So the effective capacitance for these 3 that are in parallel is going to be what? Equal to, just add up these capacitances. So you have 2 plus 2 plus 2, and that is 6 microfarad. Now this 6 microfarad will now be what? In series with this one here. No, it's now be like as if you have 2 microfarad there, then this line now have 6. That's after we have, find the effective of all of this. 6, then 3 microfarad. So now we now have 2 microfarad, 6 microfarad, and 3 microfarad connected in what? In series. We then find the total capacitance. So how do you find the total capacitance? It will be what? If you have 3 capacitors, let's say C1, C2, and C3 that are connected in series, then we say that the total capacitance is 1 over C is equal to what? 1 over C1 plus 1 over C2, okay, plus 1 over C3, excuse me, plus 1 over C3. That's what we're going to have. So our C1 is going to be like this 2 here. The C2 is going to be the effective of this one here, that's 6, plus the C3 is going to be 3. Then here, so let's solve this out. If we take the LCM of the denominators are 2, 3 and 6. The LCM is 6, right? So we then say 2 in 6 is 3 times 1, so you are going to have 3 here. Then plus 3 in 3 is 2 times 1, you are going to have 1. Sorry, you are going to have 2. Then plus 6 in 6 is 1 times 1 is going to be 1. Then when you add up these numerators there, 3 plus 2 plus 1, you add 6 over 6. And 6 over 6 is what? 1 over 1. Alright, so that means that this thing that I have is going to become 1 over 1. If you now have 1 over CT, the total capacitance, is equal to 1 over 1. What will be the value of your CT? You just compare both sides of the equation. 1 to 1, CT to what? To 1. So your CT here, the total capacitance here, is 1 microfarad. Alright, I hope this is understood. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at Collab. Okay, like and share our content, and visit our website at collab.com to practice UTME exam and modular quizzes for free. Thank you.